What page is this? Okay, everybody turn to page 2. The first part is showing you the difference between GCF, which we've done, and this new idea of what's called LCM, which stands for least common multiple. So, this is a revisiting of 18. So if I gave you the numbers 6 and 9, what is the highest number that can go into 6 and 9? Adam. Agree? 3, everybody? You can do that in your head, right? You don't need to do factor trees, right? Now I'm going to turn it around. That's our GCF. What if I now ask you, what's the smallest number that 6 can go into and 9 can go into? So automatically you got to be thinking, okay, we got to think higher numbers now. I need a number that 6 goes into and 9 goes into.
18.
Oh, raise your hand. Everybody's got their hands raised. You got to wait your turn. Do we agree 18? There's nothing lower than 18 that 6 can go into, right? And 9, because 6 can go into 12, right? But 9 can't go into 12. So yes, 18 is the smallest number that 6 and 9 go into. That's called the least common or lowest common multiple. You're thinking of the other way around. You're thinking of what number goes into 6 and what number goes into 9. I'm asking it the other way around. I need a number that 6 goes into. 6 can't go into 3. It's smaller, right? So it's got to be at least as high as 9, but probably greater. In this case, it's 18. Okay? Make sense? There's 2 ways in which to find LCM. Let's just say you can't do it in your head. The 2 ways are called skip counting. One way is skip counting. You count by 6s, multiples of 6. That's where the M of LCM comes from. And count by 9s, and the first number you come to is your hit. So what's the first number that both counting by 6s and counting by 9s, what's the first number that makes a double hit? 18. So you could circle it. And 18 is your least common multiple. Make sense? It's called skip count. You're counting by those 2 numbers. If I gave you 10 and 15, count by 10s, count by 15s. Where do you get your first hit? Count by 10s, count by 15s. Count by 10s. Count by 15s, you. Still no further. There's my hit. Okay? Always think higher. It's not what goes into 10 and 15. It is what does 10 and 15 go into. 10 goes into 30 3 times. 15 goes into 30 twice. It's the smallest number that the 2 numbers go into. Okay? Second method. And I got to do a little erasing because I forgot to erase them last year. So, get rid of this. Get rid of this. Sort of. Yeah, I forgot to erase it. Or it got saved. Okay. Second method, it's going to seem like more work. But in the long run, I think it's the better method. Because it involves factor trees and you've already done it. So I'm going to make a factor tree for 6. I'm going to make a factor tree for 9. 2 for 6, please. Somebody raise their hand. 2 for 6. 2 and 3. Good, all caught up. Now you know GCF. Well, sort of. They're both prime, so you circle them. Serenity, 2 for 9. Both primes, circle them. It follows the same rules as GCF when you make your factor trees. You're also going to find common factors like you do with GCF also. Give me a number you see in both trees. Cross it out in each tree, but list it how many times? Uno, once. Anything else? Nothing else, right? GCF is 3, right? Agreed? Okay, now, ready? This method is called treasures times trash. Your common factors are your treasures. Gold, okay? Your diamonds, you like those. Those are our treasures. Anything that gets left over, left behind, are your trash numbers. Those are the numbers that are circled but not crossed out. What's circled but not crossed out? A 2 and a 3. List them both. Now I can cross them out. Treasures times trash. Treasure times trash. What's 3 times 2 times 3? 18 is your LCM. Treasures times trash. So what we did, the major advantage is that most of this, like 2/3 of this, you've already done because you have experience with factor trees and GCF. The new part is now what to do with those trash numbers. Whatever's left over and not crossed out gets multiplied by your common factors. Let's try another one. Do you have this next page as your next page? Do you have this at the top? You have two numbers, 11 and 5, right? They're both prime numbers. They don't have a GCF other than 1. Do you agree? So technically, if I make a tree for 11 and make a tree for 5, no branches from 11, right? I got to circle it because it's prime. No branches out of 5 because it's prime. I got to circle it, right? What's common in both trees? No, what common factors are in both trees? 1, right? Which we don't really care about. Nothing else other than 1. So there's nothing to cross out, right? They're both trash numbers. What's 11 times 5? The LCM of 11 and 5 is 55. 11 goes into it how many times? 5 goes into 55. They kind of switch roles, don't they? 5 times 11 makes 55. 11 times 5 makes 55. So if you have two prime numbers, that's kind of the rule. If you have two prime numbers, what's the easiest way to get the LCM? Just multiply them together if they have no common factors. Okay, what do you do if you have three numbers? A little different. A little different. Make factor trees first. Everybody do that. Addison. Everybody get two circled 3s for 9? All right, good. Sometimes I see, I kid you not, some kids will circle 9 thinking it's prime. I've seen it. And while she's doing that, remember, we're trying to find the lowest number that 9 can go into, 15 can go into, and 18 can go into. Not so easy to do that in your head. Not saying that you can't do it, but it could take a while. All right, step aside. Let's see. How do the trees look? Do your trees match up? Okay. Where? You still wound up, though, with 3, 3, and 2, right? It doesn't matter how you start. You'll always wind up the same no matter what. Okay? The key is when you're done, Mel, you should have a 3, a 3, and a 2 for this tree, and you do, right? Okay. All right, here's how we tackle 3 numbers, because this can be a little confusing. I need a number that you see in all 3. Lauren, I'm going to cross it out. in all three trees, how many times do I list it? Still only once. Anything else in all three? Agreed, none, right? Now watch, ready? Ready, watch. Here's the little middle step with three numbers you have to remember. Do you see a number in at least two of them? What number do you see in at least two of them? I'm going to cross out those threes. Even though it's still in two, not all three, I'm going to still list it once. Anything else in two trees? No, nothing more in common, right? These are my treasures. Make a list. These are my treasures. Everything that's left, that's circled but not crossed out, is my trash. Anything here? Nope, because they're already crossed out. Anything here? 5's a trash number. List it. Now I can get rid of it. What's left here? A 2. That's a trash number. Okay? Okay, let's do the treasures first. What's 3 times 3? Bring that down. What's 5 times 2? 9 times 10 is 90. Now let's just do a little mental check. Will 9 go into 90? How many times? 10. Does 15 go into 90? How many times? 7 gets you 105. Right, 15 times 6. Does 18 go into 90? Let's try. What's 18 times 5? 18 times 5. What's 5 times 8? 0. Carry to 4. It works. As long as you're careful, it'll work every single time. Okay, go back to 18B, exit ticket, or if you want to work in 19, you can. Where?
These are the leftover numbers, and then there's 3 in every box. So
I had a 3 in all three.
yes,
I listed it once.
yeah, and then you still have a
I'll go
3.
backwards. I'll go backwards. Let me pause this.